Okay, so I think we can proceed with the next presentation from Anna Simson from Aachen University, who will present us the compiling of fair CI score data from a user perspective.
Yeah. Oh, okay, it works. Hi, my name is Anna Simson, and I'm a PhD student from RWTH Aachen University, which is in Germany. And in this talk, I'm sharing my reuse perspective with you of compiling CI score data sets. So how I started to reuse data was in the frame of my PhD project, for which I implemented a physics-based process model for modeling sea ice evolution. And at that time, my supervisor gave me some ideas on how to continue with the model or how to improve it. And one of the ideas was to include sea ice core measurement data from that are available on data repositories. And we thought, since these data repositories are aligned with FAIR, that it would be easily reusable and quick. So I started to get a broad overview on what kind of sea ice core data is available, and some of it is listed here, next to a picture of a sea ice core. So it is, for example, the salinity or the temperature and the sea ice thickness. And then I thought about reuse scenarios for my sea ice model. So one reuse scenario could be, for example, the validation of this multi-phase, multi-physics process model. And for that, I would need data from different locations, for example, the Beaufort Sea or the Weddell Sea. And for reuse scenario B, I thought about training a classification algorithm for the development stages of sea ice that could be, for example, old ice or first-year ice. And then it would be interesting to see how the model data would be classified in this classification. So now I introduced to you these reuse scenarios, but my reuse scenarios are very specific. So I have very specific requirements for the data that I need to feed in the model or like in the specific scenario. So for scenario A, I have, for example, inputs that are the salinity and the temperature and the solid volume fraction of the ice. And there I have specific constraints, for example, a specific resolution unit, or it has to be below a certain measurement error to keep the uncertainties low. Then I need the salinity of the seawater for accurate boundary conditions. For scenario B, it is especially important that the water body and the development stages follow some specific naming, so it's not a cross-class use of names. So I need a database of all of these elements in these reuse scopes. I call them reuse scopes. And yeah, so I thought, let's compile data sets that are available. An intuitive approach of compiling these data and searching for these data is I saw it as follows. So data sets on these data repositories such as the AADC, Pangea, or Zenodo provide these data, or I thought they would provide these data sets, and it would be easily combinable because they may have some structural they may be structurally identical so that I can easily combine them. However, the first round of search revealed it is not that easy, and it is that difficult to combine these data because they are very heterogeneous, and the data sets, of course, do not best reflect my reuse scenario, but the data collection. So, but I still didn't gave up, and I worked on a strategy to do that. So I followed a reusability targeted approach for my scenarios and created an enriched sea ice core database that I call resize. So I started to search for data, and there I had some challenges. For example, that the data that are associated with one sea ice core are distributed across data sets. And then I could also look into articles where I found, for example, the accuracy of the salinity measurement, which was not available in a data set, or the names of the water bodies. So this kind of matching that I did for each of the cores, I call it element availability matching. So one data set provides me some parts of the reuse scope, some of the elements that I was looking for. Then I look for a second data set where I found more elements. Then I looked into articles and reports and into instrument manuals to fill up all these elements that are needed for my reuse scenarios. And then I continued with the next core. So while searching for the data, I also observed I had to do some plausibility checks. So one was, for example, that data sets are redundant on different repositories. This is one from the AADC, and this is from Pangea. And the data is the same, the coordinates are the same, and here in the salinity you see it's also the same data, just with one extra measurement here in this data set. You cannot see the mouse. Oh, I'm sorry. Okay, but there's one extra one. And another problem is that, for example, the accuracy was exaggerated. And that, for example, there are inconsistencies. So here was the ice thickness given with 0.43 meters, but then the measurements went up to 0.85 meters. So I collected all these data sets per sea ice core and assembled them. So in the next step, I technically combined them, everything that I found, and I created one YAML file per sea ice core. And what I want to raise your attention is mainly this comment section. This moved a little bit. Where I refer to the figure where I've taken this information from, then excerpts from an article, for example, and things that are changed, like if I change the unit and if I change the accuracy and so on. So it's very manual. I did this like a lot of copy pasting and so on. And I also always share the GUI in each of these properties, for each of the properties. So in the next step, these YAML files can then be compiled for the database. And so this is an overview on the availability of the different elements of the database. So here on the y-axis, you can see all the YAML files or all the CI scores on the x-axis, and on the y-axis, you can see all the elements or properties. So if it's dark blue, then it is available from a data set. If it is this little bit lighter blue, it's from an article or a report. If it's this color, it's from a manual, and if it's yellow, it's not available. So what is interesting, I think, is uncertainty is very important for me, but I could only find the accuracy of the devices in the data set almost never, except from one. I can't find it right now. What this trace, this doesn't show as I wanted. Okay, generally, wait, does it maybe show now? No. Okay, it doesn't matter, because if you are interested, you can check it in some extra source that I provide at the end. So this is one path of one of this YAML file. This YAML file here, so what x-axis is again CI scores or YAML files, and this YAML file here with this here at the top gets data from 3 data sets, from 2 articles and reports, and from 2 manuals. So it reveals how the data is stored also by the people who collected the data. So now with this I have consolidated all existing sea ice data that I found. But I also did some automatic enrichment for some of the elements. For example, the spatial resolution, the sea ice development state, and the name of the water bodies, since they were not following these controlled naming that I wanted them to have. So the resized database is real, and it is also publicly available in the interactive Mosaic Web ODV provided from AVI. So on the top, you can see all the locations of sea ice cores. And here are all the, on the lower left are all the salinity data from sea ice. And on the lower right, you see the development stage, for example. So in summary, what did I do? I used original sources. I used data sets. I used articles and reports and manuals, and additionally these nomenclatures and controlled vocabularies. I went through all 4 steps that I just went through, like the formalization of the reuse perspective, the plausibility checks, and the technical combination. Then I consolidated all data in YAML files and developed this resize living database where each YAML file for each core. Then I continued with the automatic metadata enrichment. And the following database, it's a resize tabular database named here, is then exported to Mosaic Web ODV, or I also created I also uploaded the database on Zenodo. I had to split it into 2 parts because of different licenses of the original sources. So if you're interested, you can scan the QR codes and see, for example, the lower left is the correct version of the plot that didn't work properly. Thank you.
Interesting presentation. Are there any questions for Anna?
Thanks a lot. It's a very good thing to showcase the data use and all the work that goes into utilizing heterogeneous data sets. You've done a lot of work in improving the quality of the data you've fetched. And I was wondering if there's any mechanism for you to feed back that information to the data sources you got the data from. The ideal place to make corrections, if there are general corrections, would be in the source databases. Is other that kind of mechanism in place to give that feedback to them?
That's a good idea. Actually, I was mostly looking, of course, focusing on my reuse scenarios. So I didn't think about it yet, but I can try to reach out to Pangea also and tell them here's some accuracy issue, for example.
Okay, thank you. Other questions? I think no.